Hello, mathematicians. We are going to math it up today with data. Today we're going to be covering mean absolute deviation, otherwise known as MAD. So what is mean absolute deviation? Well, it talks about the average distance between the numbers in a data set and the data set's mean. So it's looking at how far the data points are on the average, and you're hearing that word average, so you know means involved, on average from the mean of the data. And we'll look at that very specifically and calculate that. So it really is referring to how spread out the data is, how much does our data differ. We're looking at things like that to see if the data is far spread from the mean or if it's tight close into the mean. That is what it is. So what is MAD? So it comes from these three words, mean. Well, we know the mean is an average, and we will use average twice in arriving at the final MAD. We will use it first on our original data points, and then we will use it again on our differences. Absolute, the word absolute is in there because we are going to be finding the absolute distance between numbers. So no consideration as to whether it's negative movement or positive movement. We're just getting that absolute value of the distance between our numbers. And then deviation is really about the differing from the mean. That's where the deviation part comes in. So we're going to get MAD in 3 steps. We're going to find the mean of our data points. Then we're going to find the absolute distance between each data point and that mean we arrived at. And then we're going to find the mean of the distances. It's really quite simple. Sounds more complicated than it is, I assure you. So let's get into it. So here's our first set of data. So here are our steps we talked about. I do like to use a data table. It is not necessary. You can absolutely do this without a data table, but we'll use one today together. And I do like to put my data points in number order. 2, I think it just helps to make sure that your numbers are making sense. So I'm going to list my data points here in this first column. So I'm going to start with my 5, and I like to strike my data as I use it so that I do not get confused and use a number more than once or miss a number. I know this is a very short list of numbers, but sometimes they are long, and that is a helpful little trick. And I wrote a 15 instead of a 12. Let me just correct that. There we go. Okay, now I have used my 5 numbers. I have them in number order. I can tell all kinds of things from this data set. I know my range of numbers is 7. I know my mode is 10. I know my median is 10. And now I'm going to find my mean because that's what I really do need for this. So we're going to go ahead and add up these numbers. And we have 12 and 10 is 22, 32, 40. Looks like 45. So I'm going to put my total here because we are getting the mean. And then you see the little division sign there. And we're going to divide by the number of numbers we have, which is how we arrive at the mean, and that is 5. So our mean of this data set is 45 divided by 5, or 9. Okay, so I'm going to write in here the mean. The mean was 9. Okay. And now this is where the absolute part comes in. I don't care about the 5 being first or the 9 being first. I just want to know what the distance is, the absolute value of the distance between those numbers. So we could do the subtraction problem and put it within the absolute value signs, but at this point, we're just thinking about how many numbers are between these two numbers. So here we have 4 between. Here we have 1 between. Here we also have 1 between. See how that works? We have 1 between, and here we have 3 between. All right, so the second part is done. We have found the absolute distance between the mean in each of our data points. That's right here. We did this, we got the mean here, we've done that. Now we're going to find the mean of those distances. So we're just starting back over with doing a mean. So we're going to add, we know we're dividing by 5 because we have 5 numbers here. So 4, 5, 6, 7, 8, 9, 10. Well, that's handy because 10 divided by 5 is 2. So the MAD for our set of data is 2, meaning that the average distance of all the data from this mean of 9 is 2 points, 2 points away. So that tells us that our data is fairly close, and you can see that by looking at the list of data. Sometimes it is much more spread out, but in this case it is close. All right, so here's where we're going to invite you to stop the video and try this one on your own, and then start the video again, and we will go over this together so that you can check and correct your work. All right, welcome back, and let's go ahead and take a look at the second data set. So here we go. Again, I'm going to use the table. You don't have to, but I like it for this type of work. So I'm going to put my data points in. I have a 9, I have a 10, I have an 11, I have a 12, and I have an 18. Again, I can determine the range of this data. The upper extreme is 18, the lower extreme is 9, the difference between is 9, giving me the range. I can see that there is no mode here, but the median is an 11. But what I need is the mean. So we're going to divide by 5 here, but let's get that mean. So I have 9, 10, 20, 2, 3, 4, 5, 6. Looks like we have 60 divided by 5. And of course, that is 12. So that is the mean of my data. So I'm going to put that here. And now I have to determine what the distance is between these numbers. So again, 9 to a 12 is going to be 3. I don't care about direction. I just care about distance. 10 to a 12 is 2. 11 to a 12 is 1. A 12 to a 12, there's no distance there. And 18 to a 12 is 6. And what's important here is that even though one of these numbers is a 0, 0 is a number and it is a piece of data. So we do have to count all 5 of these and divide by 5 when we're finished here. So we have 6, 7, 8, 9, 10, 11, 12. And we have 12 divided by 5 for our MAD on this one. And of course, 12 divided by 5 is going to give us 2.4. So our mean, our mean absolute deviation for this data is 2.4. And even though the data points are quite different, it turns out that the data isn't that different at all in terms of the spread from the mean from the last set. So here is one more problem that you can do on your own. And as always, thanks for watching. Thanks for advocating for yourself. And we'll see you next time.